Page 60 and 61. Remember, 60 is our study guide and review. There are two question blanks up here. Changes in motion are caused by blank, and blank laws describe these changes in motion. Okay, feel free to look at your review to get those two answers, or to answer any of the other questions that we're coming up to. Lesson 1, the nature of force. When a non-zero net force acts on an object, the force, A, changes the motion of the object, B, must be greater than the reaction force, C, does not change the motion of the object, D, is equal to the weight of the object. Number 2, the SI unit for force is the blank. So what was the SI unit? What did we have to put behind it? Number 3, calculate. What is the net force on the box? And be sure to specify the direction. Lesson 2, we talked about friction and gravity. Friction always acts as A, in the opposite or in the same direction as motion, B, opposite the direction of motion, C, perpendicular to the direction of motion, or D, at 30-degree angle to the direction of motion. What does friction is what we're talking about, always act as? The factors that affect the gravitational force between two objects are what? We had two factors, or between two objects, the factors that affect it, okay? 6, list what are two ways you can increase the frictional force between two objects. And 7, let's write about it. Design a ride for an amusement park. Describe the ride and explain how friction and gravity will affect the rider's design. Lesson 3, which of Newton's laws of motion is always called the law of inertia? So another name for the laws, Newton's laws, was it the first one? B, is it the second one? C, the third one? D, the fourth? Question number 9, Newton's second law states that force is equal to, go ahead and answer that question. Interpret the diagram. Look at the diagram below of two students pulling a bag of volleyball equipment. The friction force between the bag and the floor is 4 newtons. What is the net force acting on the bag, and what is the acceleration of the bag? Go ahead and show your work in this space. 11, suppose you are an astronaut making a spacewalk outside your space station and your jetpack runs out of fuel. How can you use your empty jetpack to get you back to the station? And apply those concepts of gravity and force and friction.